Okay, question number 2 says, what scenario could be modeled by the graph below? So if you look, we have this graph here. The first couple of things I noticed about the graph, and as you are working on your test, there are different things you could do to take notes just to get your thoughts in order. First thing I know is that it is a linear graph. Okay, I notice it is a straight line here. I noticed that there is also this shaded region. Okay, so that tells me that what I'm dealing with here is not an equation, but it is going to be an inequality. And just remember, inequalities are the graphs or the functions that start usually with y is greater than, y is less than, y is greater than or equal, or y is less than or equal. Okay. And as I look at this graph, I notice it is a solid line, which means that the equals part is part of the equation, so that cancels out these two. If it was a dotted line, it would either be y is greater or y is less than. A dashed line, it would be one of those two, but since it's not, but there is some shaded part, it's one of these two right here. Okay. Then I noticed that if I was to pick any point on this line, the area below that value is shaded. So of these two, that's going to be y is less than or equal to. Okay, so just my thoughts when I look at this is I start to notice what type of inequality this is. Alright, so I'm looking for an equation or a situation that is represented by y is less than or equal to, and then whatever the equation of the line is. So to look at the equation of the line, I notice that it does cross the or touch the y-axis. Choose a different color here. Crosses the y-axis right about here, which is a y value of 5. So that is going to be my y-intercept. Okay. All right. So if I was to write the equation out, I would know that y is less than or equal to 5. That can be my starting value. And as I look at the graph here, it looks like every time I go over 1, it looks like this is going to be the place where we go over 1. We are going down from 5 to 3, so that's down 2 and over 1. Okay, so that means my slope, remember slope is the change in y over the change in x. So my change in my y went from 5 to 3, so that's down 2. Over, I went from 0 to 1, which is positive 1. So negative 2 over 1 is just negative 2. So that means my equation becomes y is less than or equal to 5 minus 2x. Remember, the slope goes with the x. Okay? So basically I'm looking for some situation that starts at 5, or it looks like the biggest value is right there at 5, and it's decreasing by 2 times whatever x represents. So let's look here. This first one says the number of pounds of apples, y, okay, minus 2 times the number of pounds of oranges, which is our x, is at most 5. Okay, so this is saying y minus 2 times the number of pounds of oranges is at most, so think about what at most means. That would be less than or equal to 5. Okay. So if we were to put this in y equals form or in an equation form, all right, let me clear out some space over here. Or actually, let's go ahead and do these other ones first, then I'll go back through and put these in y equals form. This next one says y minus half the pounds of oranges is at most 5. Okay. This next one says y plus 2 times the number of pounds of oranges is at most 5, so less than or equal to 5. And then finally, y plus half the number of pounds of oranges is at most 5. Alright? So as I'm going over this and looking to see which one of these equations actually works out, I'm just going to clear a little room out over here. What I have to do with these equations is these aren't in y equals form, they're not in slope-intercept form, so to do that I just have to get the x's on the other side. Okay, So if we have y minus 2x and I want this negative 2x on the other side, I can't just move minus 2x over here. I have to cancel out these minus 2x's. And to do that, if you have y minus 2x is less than or equal to 5, to get y by itself, that means we would have to add 2x to both sides. Okay? So this first one would end up being y is less than or equal to, because these would cancel each other out, so all we'd be left with is y, 5 plus 2x. Now remember, the equation we were looking for is y is less than or equal to 5 minus 2x. Alright? So this is very close, but it's not going to be right because this is adding 2x. Okay? So that means A doesn't work. If we look at this one, we can kind of get the idea. We would have to add 1/2 x to both sides, so this would become 5 plus 1/2 x. That's not what we want. Part C says y plus 2x is less than or equal to 5. So here we would have to take away 2x from both sides. Alright? And that would we would be left with this y. We would bring it down. These 2x's would cancel out. And I would get y is less than or equal to 5 minus 2x. They're not like terms, so I can't combine them. And this does in fact match what I'm looking for. So my correct answer should be C. And just to finish these off, to cancel out the 1/2 x, we would have to take it away from both sides. And this would become 5 minus 1/2 x, which also is not what we want. Okay, so the correct answer here would be C.